Hello. So in this section, we're finding the asymptotes of rational functions. In this one, there's a constant over the linear function. So all of them will be set up like this, which means that the horizontal asymptotes are all going to be the same. But if we look at the function, f of x equals 7 over 3x minus 9. Vertical asymptote. The vertical asymptote comes from the domain. The values in the domain can be vertical asymptotes. To find the domain, we set the denominator equal to 0. And we get a negative 3. So x cannot equal negative 3. Vertical asymptote, notice this will not reduce. As long as it does not reduce, this is your vertical asymptote. Horizontal asymptote, we look at the degree, and the degree on the top is 0 because it's a constant. The degree on the bottom is 1 because it's x to the first power. When the degree on the bottom is larger, the horizontal asymptote is y equals 0. Let's try another one. So first you have to find your domain. Setting the denominator equal to 0. We get negative 1. So x can be anything except for negative 1. Since this will not reduce and cancel this factor out, it's a vertical asymptote. To find the horizontal asymptote, we look at the degree. The degree on the top is 0. The degree on the bottom is 1. The degree on the bottom is 1. Since the degree on the bottom is larger, the horizontal asymptote is y equals 0. So you would just be, I think you just have to graph these. So you would tell it where to graph it. Like the vertical asymptote hits the x-axis at negative 1. Horizontal, all of these are right on the axis for the y because it's a constant in the top. This one would be x is negative 3, so it hits the x-axis at negative 3. And again, this one's at y equals 0. One more. So first thing we do is find the domain. X plus 2, we set it equal to 0 and solve. So x cannot equal negative 2. Since this will not reduce, that is our, I don't know why I put f of x. That is our vertical asymptote. To find the horizontal, we look at the degree on the top, which is 0, the degree on the bottom, which is 1, and our horizontal asymptote is y equals 0. So that's all that's to these ones. Let's look at the next set. So in this one, notice the degrees on the top and bottom. It's a little different. We don't have the constant. Okay, so first thing we want to do is set the denominator equal to 0 to find the domain. So the domain is x cannot equal -2. This function will not reduce, so that is a vertical asymptote. Oops, equals. For the horizontal, we look at the degree. The degree on the top of this one is 1, and notice the degree on the bottom is also 1. When these are both the same, for the horizontal asymptote, you set these two not equal to each other, but over each other, and you reduce it. It will approach these two values. So we have -3, well, the x's cancel, but y equals +3. So our horizontal asymptote is y equals 3. Try another one. First thing we do is find the domain. For the domain, we get -1. So x cannot equal -1. This will not reduce because the top's not factorable. If it were factorable and we had x plus 1 and those canceled, then this would be an open circle. But it doesn't, so it's our vertical asymptote. The degree on the top is 1, the degree on the bottom is 1. When these are the same, they reduce, so we take these two terms. The x's will cancel. We have a -6 over a -3. So y equals a +2. And that's all that's to those.